Okay, let's look at this shaft support assembly. You've got PDF files that show the parts that you're going to create. The base plate here, and notice it has threaded holes, excuse me, in those. Uh, let's see, the bearing, uh, this one uh, may be a little confusing. Dimensioning from isometrics and Inventor is kind of difficult, but the overall height is 2 inches from this surface to the bottom surface is 2 inches overall. Excuse me. This hole should be on the left face as you're looking at it here, okay? Or the front, depends on how you created the part. And you've got countersunk counterbore holes here. Sorry, counterbores. Um, and another thing, I probably haven't addressed this in any other videos, but as far as applying the material finish, best to do it, go ahead and go to iProperties and do that and apply your material here. Okay, cast iron. And for some reason, a lot of people, their pattern is coming up as just iron or something other. It doesn't have this look. So if that is the case, then come to here, get a pull down. Okay, and then go to iron cast. Okay. Now the machined surfaces, as you can see, I've changed them. And if it's machined or finished, I select those surfaces, and you can select multiple surfaces by holding down the control key, and then come up here and change that surface to chrome polished. Okay. Now drilled holes, I tend to use the machined. Which one is it? Machined 3 on the inside, like drill holes, so it gives it kind of that appearance of being machined or cut or drilled. You don't have to. You can just make that chrome too. That would be okay. But anything that's a mating surface usually gets a finish on a cast iron part. Okay, the cap screw. This one, maybe it's best to create this one as a revolved feature. Excuse me. And here's the sketch that I use. Okay. All right. Notice the notch is not here, the slot. Okay. You just draw the whole thing out and revolve it. Then come back in and do your sketch on that center axis and then extrude both ways. Okay. And if you notice, I made a rectangle that's centered up. I got my dimension correct here and my width, and then I just gave it a long dimension out here to get it outside of the part. It doesn't have to be that far outside, but as long as it's outside the curvature so that it'll go all the way through. Okay. And then you apply a thread uh, to the surface, and this is just a cosmetic thread. Um, okay, waiting. I don't know where. There it is. Okay, took it a little while to come up. For the face, you choose the cylinder, of course. And we're going to go with a length of 5/8 of an inch, okay? Because it will not be threaded all the way up to the top surface, but just go 5/8 of an inch. Okay, specification is where you choose. Here we go. It's an ANSI unified diameter 3/8 by 24 UNF, okay? And then you'll apply that, and then you'll put a chamfer on the end of the screw down there, okay? Let's see, the collar, pretty simple. Cylinder with a couple of chamfers applied to it. And then the assembly will look like this. Okay, so I'm going to go through assembling and constraining here. So I've got a new assembly opened up, and I placed my first part in. And when you place that part, if you do not get a grounded icon, you need to go back and change the options in your program so that it grounds the first part placed into an assembly at the origin. If it didn't do that for you, then right click on it, come down here and click grounded. And what that does is that keeps it in place, and it won't move in relation to your view cube. Okay. All right, so I want to put my next part in. I'm going to go with the bearing, and I'm going to drop one in. All right, now I'm just going to use straight up constraints on this, since this is our first. We're kind of early in assemblies, and we'll deal with joints later. So I'm just going to go with just straight up constraints. I'm going to go constraint. I'm going to go mate, and I'm going to choose top surface of that, bottom surface, and I'll hit apply. Okay. And now I want to align the holes, and I'm not inserting anything. I'm still going to use my mate constraint, but I want to choose the axis of the hole and the axis of that hole, and I'll apply that. And then I'll do the same for this other hole here. Come on, there we go. Okay, now that's got that constrained. Okay, so that one's in place. And then let's see, the bearing. That was the bearing. Let's go with the collar. Okay, now with this one, we can use an insert constraint. So we'll go insert. And what I want to insert is this part of the cylinder, but I want that ring right there. And I want it to go inside that ring of this cylinder. Okay, and I'll apply that. And you want to look at that and make sure the part doesn't, it's not, recessed down in there. A good way to do that is to go to your view tab and switch over to wireframe, and then take a look at it. Make sure it's it's in there good. Okay. Oh, didn't want to do that. Let's change back to shaded. Okay, so next we have our screws to place. Okay, now we can use the insert constraint here also, as long as you're careful with where they go, just like before. So we'll go with an insert. And we'll choose that. And that. Now, you see that can still rotate, and we're going to want to constrain those rotationally. But we want to, just like before, you want to check and make sure that that's in the counter bore correctly, that it's not way down, recessed or up in the air or something like that. Now, if we look at this, you notice the screws highlighted in blue. It appears larger than the hole here at the bottom. That's because the way Inventor shows this is the threads right here. This is the minor diameter of the threads of the hole, major diameter of the threads of the screw. I'm going to pause the video here and then we'll pick up again in a moment.